So, good evening, everyone. This is lecture number 3, JEE Advanced, and we are dealing with thermodynamics. In the previous class, we had seen the different processes and we were doing some questions on that. Okay,
Sir. Yeah.
right? So, let us continue. And today we will try to wind off this thermodynamics with a mixture of questions starting from thermodynamics, calorimetry, heat transfer, and so on. So we'll try to wind up this thermodynamics. Okay. The question that we are going to start is the question that we did in the last class, and I told you about this. A similar question I did last year, and it came in JEE Advanced. So let us start with this. I hope I've sent you the sheet. Probably you might have seen this question. So this question goes like this, and these are the type of question that you might expect in comprehension type. So this is example number 36. 1 mole of a monatomic gas occupies, so the same gas, 2 chambers of a cylinder partitioned by means of a movable piston. The walls of the cylinder as well as piston are thermal insulators. Now there could be a variation of this question where the walls of the cylinder are thermally insulated, but the walls of the piston is a conductor. You can very well see the question. If I get it, probably I would have that question also. So we will deal with that question as well. Initially, equal amounts of gas fills both the chambers. So the pressure is P naught, volume is V naught, and temperature is Q naught. A coil is burnt in the left chamber. So you can see a coil. This is a heating coil, which absorbs heat and expands, pushing the piston to the right. The gas on the right chamber is compressed until the pressure becomes 32 P naught. So do we understand the question? Yes or no? Understand the scenario of the question. And now they are asking the first question. This is a comprehension based question. What is the final volume in the left chamber? So have you tried this question before?
No, sir. I will try now, sir.
Okay, so I'll give you 2 minutes. Think about this question. The first part, it has 2 or 3 parts. Let us try the first part first. I'll give you time. Well, I think it would be better if I tell you all the 3 questions first, which are being asked. The first question is obviously what is the
Sir,
final
15,
volume of the
15
left
V naught by
chamber?
8.
Then there is work done on the gas in the right chamber and the change in internal energy in the left chamber. So there are 3 questions here. I think you've got the answer for the first one. Let us
Yes, sir.
give you time.
15 V naught by 8.
Okay. And then there is work done on the gas in the right chamber and change in internal energy in the left chamber. So I'll give you time for that. I hope that you can get the answer and then we'll discuss how it has to be done. 2 minutes. So basically, how are we going to solve this one? Remember, we don't know what is happening, what type of process is happening on the left hand side of the chamber, but we definitely know what is going to happen on the right hand side of the chamber. Yes or no?
Yes, sir.
What type of process is happening here? The process
Adiabatic process.
Adiabatic process. P naught V naught raised to the power gamma is P final V final raised to the power gamma. Yes or no? Initial pressure was P naught. Final pressure is 32 P naught. Yes or no? Because pressure has to be same on both sides. Otherwise, the piston will not remain in equilibrium. You put the values and you will get the first answer, which is the volume on the right hand side. It is 15 by 8 V naught. That's correct.
Yes, sir.
Work done on the gas. It's an adiabatic process. We know the final pressure, we know the initial pressure, we know the final volume, we know the initial volume. You can find out the work done on the gas, right? Work done on the gas, they are asking, so it is always positive. It is expanding, right? Work is done by the gas, but if you take it by the gas, it would be coming out as negative. Do you understand this? Because it is getting compressed, right?
Yes, sir.
Right. So therefore, they have used the reverse formula. and they'll not, they definitely they are not going to get negative. Therefore, they are getting the positive value. Do you understand this?
Yes, sir.
Okay. Now comes the third part. What is the change in internal energy for the left hand side? How do you get this? Hmm? Remember, we don't know what the process is, but we definitely know for any process, the change in internal energy will always be equal to,
NCVDT.
we know the initial
19.
pressure,
Yes, sir.
we know the initial
Equal.
volume, we know the final pressure, we also know the final volume because we know the volume of one side, so we know the volume of the other side. From here, you can get the temperature on the left hand side. Yes or no?
Yes, sir.
PV is equal to nRT. Number of moles will not change, right? So from there, you can find out the change in internal energy of the gas on the left hand side. Yes or no?
Yes, sir. Clear.
There could be a variation of this question where they also ask you what is the heat absorbed or heat given by the coil that you had put. How will you get that? That question is not asked here, but it could have been a different question. They could have asked you how much heat is given. How would you do that then? Hmm?
NCVDT delta Q equal to.
How would you do that? Any idea?
No, sir.
It's simple. To get delta Q,
NCV.
you already know what is delta U, yes or no?
Yes, sir.
You just add the
Yes.
work done. Now remember, you do not know what process is happening on the left hand side, but you definitely know the process on the right hand
Right
side, and
hand
you had
side.
calculated the work done for that process, right? Work done what for that process was negative, right?
Oh, yes,
Work
sir.
is done on the gas. It will be coming as negative, yes or no?
Yes, sir.
Now whatever work has been done on the left hand side has been done by the gas on the right hand side. So the reverse of this would be the work done on the right hand side, yes or no?
Yes, sir.
Yes or no? Do we understand this?
Yes, sir. Yes, sir.
So therefore, you know the value of delta W as well.
Delta W.
You know the value of delta U.
You
You can easily
delta, yes,
calculate
sir.
heat given or
Delta Q
heat
equal to delta
absorbed.
U plus delta W.
Yes,
Okay, sir.
yes. Do we got this? We get
Yes, sir.
this?
Yes, sir.
Yeah, so this is how you apply simple things. You may not know the process in both the chambers, you will definitely know, but then if you're able to understand the process on one side and you can calculate it for one side, the other side automatically comes. Yes or no?
Yeah, yes, sir.
Remember this. It might come in exam this year around. Shall we move on to the next question?
Okay, sir. Sure.
Okay, so the next question is the next one in line, and the question looks like this. 1 mole of an ideal atomic gas undergoes a cyclic process from 1 to 2 and 2 to 3 and 3 to 1. Temperature at point 1 is 300 Kelvin and the process 2 to 3 is isothermal. There are a couple of questions here. What is the net work done by the gas in the complete cycle? That is the first one. You have the sheet with you. That is the first one. Then you have a couple more, 40 and 41. And it goes at heat capacity for the process 1 to 2 and the efficiency of the cycle. I'll give you 2 minutes to deal with this. So tell me how you have done this so that I understand.
Yes, sir.
Tell me how you have done this. Is this the exact way you have done this to find out the work done in the complete cycle?
Yeah, yes, sir. Work done of 1 2, work done of 2 3, 3 1.
2 to 3 is a isothermal process. 3 to 1, I think, is an isobaric process, right?
Yes, sir.
And in process number 1, I think P is directly proportional to V, right?
Yes, sir.
So you have calculated that. Great. Then to get the value of C, what you got to do is find out the heat. The heat,
delta Q equal to NC dt. Then you have to C equal
how
to
did you
delta.
calculate the value of delta Q?
Sir?
How did you get the value of delta Q?
Nice, sir. C equal to delta Q by N dt.
Yes.
We have when I calculate heat capacity.
Okay.
And delta Q 3R by 2 dt
Okay. Okay. Got it. Got it. Got it. Got it. Got
plus
it.
dW.
Yeah. You got it. Okay. Then you get the efficiency of the cycle as well. From 1 to 2 to 2 to 3. How much work has been done? One was isothermal process, one was isobaric. So you have done it correctly. Congratulations. You've done it in exactly, beta?
Yes, sir.
Okay. So let us not waste any more time on this. Then let us move on to this one, where you have a match the following type of question. Let's see if you can do this one. An ideal gas whose adiabatic component equals 7 by 5 expanded according to the law P is equal to 2V. The initial volume of the gas is V naught, 1 unit. As a result of expansion, the volume increases 4 times. R is to be taken as 25 by 3. Work done, change in internal energy, heat supplied, molar heat capacity, and you have the various options. I'll give you 2 minutes to solve this. Let us see how it's to be done. Now, this is how the solution has been done in this. I mean, you can obviously follow this and do it this way, or it's a polytropic process, right? P is given as 2V. Yes or no, bacha?
Yes, sir. P equal to 2V.
So I can write
Yeah.
this process as like this. PV raised to the power minus 1 is equal to a
Minus 1 equal to
constant.
sir.
Yes or no?
Yes, sir.
So here the value of n becomes equal to minus 1. Yes or no?
Yeah, yes, sir.
For a polytropic process, then I can use the formula for polytropic process and I'll get my answer. Remember, to use the formula, you need the change in temperature delta T, and you can easily calculate the change in temperature delta T. Yes or no?
Yeah.
You know the initial pressure, you know the initial volume,
Initial volume and you have to
so you
find the
know the
initial
final
temperature.
pressure. From there you can change that. From there you can calculate the value of nr delta T. Yes or no? Which is coming
Yes,
as the
sir.
PV naught square. You just put it in the formula for work done in a polytropic process, and then you don't have to do this or this or this anything, right? You can straight away get your answer from here. As you can see, they have used it in the final thing. You can use this one formula and you will be able to get all the results together. Yes or no? Do we understand this?
Yes, sir.
Okay. Then comes this question. We are doing enough questions on this topic because I know that 1 or 2 questions would be there in the exam based on this. So here comes this question. The pressure, the figure given shows different process for a given amount of an ideal gas. W is the work done by the system, and delta Q amount of heat is absorbed by the system. A theory-based question. In the match the following. I'll give you 2 minutes to tell me the correct answers. Let's go about your first answer is correct. Do you want me to explain this? Do you
No, sir,
understand
I can
this?
understand. Yes, sir.
You understand this? Yes or no?
Yes, sir.
Your second option is also correct.
Oh.
Your third one is also correct, but your fourth one, your 2 options are missing. The correct answer is P, Q, R, and T. P, Q, R, and T. That is the work done is greater than 0. Do you see this first diagram? What type of process is this? P is directly proportional to 1 by V. Yes or no?
Yes, sir.
So this is an isothermal process. Yes
Isothermal
or no?
process. Yeah.
This is an adiabatic process. This is an isobaric process. This is a cyclic
Yeah,
process.
cyclic process.
and this is a polytropic process. P is directly proportional to V. P raised to, right? Now,
Yes, sir.
now, in this process, volume is increasing. Wherever volume is increasing, work done is greater than 0. Yes or no?
Yes, sir.
So, so it is increasing in P. Yes or no?
Yes, sir.
It is increasing in Q. Yes or no? It is increasing in R. Yes or no?
Yes,
It
sir.
is increasing in T. Yes or no?
In
The only process, the cyclic one, so the cycle is anti-clockwise, the net work done in the complete
yes, sir.
cycle is less than 0.
In cyclic, it is not process, sir. Okay, I can understand.
In cyclic process, the cycle is anti-clockwise. Do you understand this?
Yes, sir. Yes, sir. I can understand, sir. Okay, sir. Clear, sir.
Okay, okay. Not a problem, not a problem. That is why we are doing these questions, so that you don't make a mistake in the eventual exam. Now let me jump on to this question. Let me first finish question of this processes type, then we'll move on to the other category of questions. So here comes the next one, and these type of questions are highly eligible for JEE Advanced. This is an integer type question. A cylinder of cross section A has two pistons of negligible mass separated by a distance L, loaded with pistons of negligible mass. An ideal gas at temperature T1 is in the cylinder where the springs are relaxed. When the gas is heated by some means, its temperature becomes T2 and the spring gets compressed by L by 2 each. If P naught is the atmospheric pressure and the spring constant is 2 P naught A by L, find the ratio of T2 by T1. T1 is the original temperature, T2 is the final temperature. I'll give you 2 minutes to solve this.
Sir, question एक बार फिर.
Yes, beta?
Oral, sir. Once explain oral question.
That is what you have to guard against, beta. If a simple question comes, you should be able to solve it. And this is simply number of moles are remaining constant. Initial pressure is atmospheric. Yes or no?
Yes, sir.
Final pressure is atmospheric plus.
Yes, sir. P1 V1 by T1 equal to P2 V by T2.
Right. Final pressure is Kx by A plus P naught. Yes or no? P1 V1 by T1 should be equal to P2 V2 by T2, and you get your answers. Correct?
Yes, sir.
Okay. Let us see the next one now. And I think you are getting better with this. All these are integer types now. So we are moving on to the integer type, and integer type are relatively simpler than the multiple choice. I think the most difficult questions in a JEE are the multiple choice. So be careful if you are attempting multiple choice, because if they have negative marking and you opt for a wrong answer, you probably would get negative mark rather than a positive one. Okay, the integer type are maybe simpler.
Sir, it will be negative marking for this year, sir. Last
Sir,
year, negative marking.
beta, you cannot predict what will happen in next year, unless and until they give you a unless and until JOSA Council or the IIT, which is conducting the JEE. I think IIT Delhi is conducting JEE. Unless and until they give a public notice, we will not be able to find out the exact nature of the paper. The exact nature of the paper will remain same. It will have single option, multiple option, match the following comprehension, integer, or maybe a decimal numbers. But the exact marking scheme may not be given. It would be known only when the paper comes. Okay, you cannot predict that. It's unpredictable. It may have negative marking. Normally, multiple choice will have negative marking if you mark the wrong option. If you mark all the right options, you will get full marks. If you mark not all options which are right, if you mark, for example, 3 options are right and you mark 2, you will probably get partial marking. But if you mark any option wrong, well, it will be negative. Got this?
Will they inform us before all? Will they inform before, sir? Before exam?
No, beta. You will probably come to know only in the examination hall. That is why you need to read the instructions carefully. If there are any such instructions released by JEE, I'll let you know by the
Okay, sir.
organizing JEE. Okay, I'm keeping
Okay,
an
sir.
eye on that. So if they release any information on that, I will let you know. Meanwhile, we can just go ahead with this question. 1 mole of a gas is taken from state A to state B, as shown in the figure. Work done by the gas is alpha into 10 raised to the power beta joules. Find the value of alpha plus beta. T1 is given as 320 Kelvin and R is given as 25 by 3. Remember, normally they will give the value of R as 25 by 3 only so that the calculation becomes simpler. Okay?
Yes, sir. Just wait, sir. I will do.
That is exactly correct. Whenever PV graph is given and work done is asked, it's simply you just calculate the area of that graph and you stay happy afterwards, right? It's a polytropic process, but you don't have to go into that polytropic process. PV graph is given, you can straight away get the value of work done by the area under the graph. Yes or no?
Yes, sir.
Right? It's a trapezium, so you can calculate the area of that trapezium. I know you can do that, so let me not waste any more time and move on to the next question. And remember, sometimes the question may look quite appealing or quite tough, but it actually may not be so. This one, a container contains a base area A naught, which contains mercury up to length L naught, and its bottom is a thin tube of length 4 L naught, having lower end closed as is having it lower and closed. The area of cross section is very small. Initially, the length of the mercury in the tube is 3 L naught. In remaining part, 2 moles of a gas at temperature T is closed, as shown in the figure. Determine the work done in joules by the gas if all mercury is displaced from the tube by heating slowly the gas in the rear end of the tube by means of a heater. Density of mercury is given and all the other things are given. Question may look enterprising, a difficult one. So basically, you understand, initially the gas is in the lower half. We will heat it, it will expand, and I want to expel all the mercury out from the lower tube into the upper side. You understand this? And remember, the area A of the tube is very small compared to the area of the base cylinder. So basically, what will happen? Why is this given? First I'll give you time to solve it, and then I'll tell you the significance of everything that is given in the question. This is an important thing that is given in the question, and you will realize it once you solve it. Give you 2 minutes to do it. So how this has to be done? Remember, one thing is given here, the area of the limb. This one is very small compared to the area of the cylinder. So what is going to happen when this mercury is going to go out in this chamber? The length of the liquid in the chamber will not change. Do we understand this? Else the question would become very tricky mathematically. Okay. So this length in the cylinder, the upper container will always remain L naught. Yes or no?
Yes, sir.
So if you talk about the pressure of the gas inside, remember the pressure here, the length of mercury column here remaining is
X.
X. So pressure will be P naught, which is the atmospheric pressure here, plus rho
P
GL
naught plus
naught,
rho
which is
G L
because of
plus.
this, plus rho GX. Yes or no?
Yes, sir.
P naught is given as 2 L naught rho G. So it becomes 3 rho naught, 3 rho L naught G plus rho GX. Work done is the integral of this. You integrate this and you get your answer of the work done. Do you understand this?
Okay, sir. Yes, sir.
This is how this has to be done. Just had to calculate the pressure of the gas inside the limb, and that pressure was not constant because the height of the mercury column was changing. That was the only trick in this question.
Calculation mistake over, sir.
Calculation mistake,
Yeah.
understood. Calculation mistake is understood, not a problem. But the concept must be correct. Do we get the correct option, correct concept, then I think I have done okay. Shall we move on to the next one?
Yes, sir.
Okay, the next one in line. This is good questions and you can do it very quickly. The relation between internal energy U, pressure P, and volume V of a gas in an adiabatic process. Adiabatic process A plus B times PV, where A is equal to B is equal to 3. Calculate the greatest integer of the ratio of specific heat gamma. Give you 2 minutes. Remember, whatever questions we get in the JEE, they are simple. Language of the question, if you understand it, the concept behind the question, if you understand it, all the question can be done in maximum 2 or 3 steps. Physics I'm talking. The calculation part may take 1 or 2 more steps. Give you this question, and I wait for 2 minutes. Let us see how this question has been done. So, for an adiabatic process, you know this, yes or no? Delta Q dQ is du plus PdV. The differential form of equation, you know this, yes or no?
Yes, sir.
This PdV is nothing but your small amount of work done dW, yes or no?
Yes, sir.
So,
It's
and this is equal to 0, yes or no? This is first law of thermodynamics, dQ is 0. So basically your du plus PdV is equal to 0. Okay?
yes, sir.
They
Okay, sir.
put it here, they put it here, they differentiate this, A and B are constant. So basically, somehow they are going to get the equation of this adiabatic process. A and B both are equal to 3. And they get the equation of process as PV raised to the power 4 by 3. Gamma becomes 4 by 3.
By 3. Yes, sir.
1.33. The greatest integer is 1. That is how you get your answer. Do you understand this?
Yes, sir.
Okay. You understand this?
Yes, sir.
Is this the way you have done this?
Okay, sir. I got it, sir.
Hmm?
I got it, sir.
Okay. Great. If you have done this, congratulations. This is a simpler one. I think you should be able to handle this one. 1 mole of an ideal monatomic gas. Gas is known. Undergo the process. Alpha is a constant. Molarity capacity is 3 beta. So beta R. R is the universal gas constant. Find the value of beta. Do it fast. I think you can do this. Yes or no?
Yes, sir. Wait, sir. CV plus R by 1 plus.
Well, that is correct. The answer is 2. You just convert it in the form of PV raised to the power
PV
x or
inverse
n.
function.
It will
Yes,
come
sir.
as -1. The value of
Time
x is
minus
-1. You just put it in the actual formula that you have derived and you get your answers. Yes or no?
Yes, sir.
Okay. One more question on this. Let's see how quickly you can do this. This is the question. 1 mole of a monatomic gas. Gas is known number of moles enclosed in a chamber and occupies the volume of 4 liters at a pressure of 100 Newton per meter square. It is subjected to the process. T is equal to alpha V square, where alpha is the positive constant. P is the volume and T is temperature in Kelvin. Find the work done increasing the volume 6 times the initial volume. Wait for your answer.
After that calculation.
So how are you going to do this? Well, you just convert this. You know that this is a polytropic process. Yes or no?
Yes, sir.
You just convert it in the form of PV raised to the power x. Yes or no?
Yeah, yes, sir.
Then you know the initial volume. You know the final volume. Yes or no? From here you can find out the initial temperature and final temperature. Yes or no?
Yes, sir. Yes, sir. Yes, sir.
From there you can calculate initial temperature, and you can calculate the change in temperature. Then you can write
Temperature.
nr delta T upon 1 minus x, and
Yes,
that
sir.
would be your answer. So if you have done it that way, congratulations, you have done it correctly.
Oh, okay, sir.
Okay,
Okay,
your
sir.
answer should also be coming correct. Yes or no?
Yes, sir.
Okay, so whenever you encounter such questions, convert them into which process? Convert them into polytropic
Polytropic
process in
process.
whatever form you want, and then just put the formula, get the answer, and then you can stay happy. Now let us move on to other type of questions. We have done enough questions on the processes. We're done with all the questions on the processes. Comes questions from other topics in thermodynamics, and this is the first one. Remember, the question might sound different, it might look different, but it may be based on a very simple concept. Two taps A and B supply water at temperatures 10 degree and 50 degree Celsius. Tap A alone fills the tank in 1 hour, and tap B fills the tank in 3 hours. If you open both the taps together in an empty tank, the final temperature of water in the completely filled tank is found to be 5 alpha in degree Celsius. Find the value of alpha. I'll give you 2 minutes to think about this. That is correct. How did you get it? Remember,
So,
the ratio of the time given to fill the tank is given. So basically, it tells you how much mass or how much volume of water will be filled by the first tap and the
found
second tap, right? If the first tap gets m mass of water in the tank, the second tap will give how much? Will get how
1
much
by
mass?
3.
M by 3, and that is the way it has to be done. If you understand this, after that, the question is pretty damn simple. Yes or no?
Yeah, yeah.
Yeah, so you just understand the concept behind it. Once you get the concept, the core concept, the question is pretty simple. Comes another one, again integer type. Example number 62. Two identical plates are welded end to end as shown in the figure. 20 calories of heat flows in 4 minutes. And this is a very common question. Find the time in minutes taken by the same amount of heat to flow through the plates. Now they're welded in a different way. This is a question from heat transfer. I'll give you 2 minutes.
We'll get then.
So basically what you got to do is, in
L
first
by.
case, both of these plates are in series, and in the second case, they are in parallel. Yes or no?
Yeah, yes, sir.
So basically, you can replace this thing by the equivalent R and equivalent L,
Yes, sir.
and you can do it that
Rho
way.
L by.
So you can understand that the time that it takes is directly proportional to L and inversely proportional to A. Yes or no?
Yes, sir.
Length has become half and area of cross section has become twice, so the time will become 1 by 4. Correct?
Yes.
And that is how you can quickly solve this question. Let us now move on from heat transfer. Again, heat transfer. And one question based on this. It can easily come in your JEE Advanced. And you must understand on what concept it is based on. If you understand that, you should be able to get the answer quite quickly. A body cools from 50 to 49.9 degrees Celsius in 5 seconds. It cools down from 40 to 39.9 in T seconds. Assuming Newton laws of cooling to be valid and temperature surrounding at 30 degrees Celsius, what is the value of T by 5? Remember, it's a simple question, but the language, what they want to ask, how they want to ask, is what you must understand. So well done. You just have to apply Newton's law of cooling, and I hope you know this average formula for Newton's
Yes,
law of
sir.
cooling. Yes or no?
Yes,
Theta 1 plus theta 2 by 2. So you have got equation number 1. From equation number 1, you get the value of k, or
got
you
the
can
K
write
value
equation number
and
1, equation number
yes,
2. Then you
done.
divide both the equations. The k will get cancelled and you will get your answer straight away. Yes or no?
Yes, sir.
This one then. Remember, the question would be very simple, but the language and what they ask in what way might be looking a bit complicated. Two rods A and B are kept as shown. The variation of temperature of different cross section is plotted in graph. Find the ratio of thermal conductivities of B to A. B is the second rod, A is the first one. Give you 2 minutes. And two, it is very simple. They both the rods are in series. The only thing you got to know is that the distance was not given. So only the thing was to
Yes.
calculate the distance from here. You see, it's a very
Yes, sir.
simple
Yes, sir.
question. Remember, and you will get puzzled to what is actually asked. The question would be pretty damn simple because questions are very simple in this chapter, and therefore there are some chapters which you have to do very religiously. Thermodynamics, electro, optics, modern. The questions from these chapters are simpler and you should be able to solve them in a JEE Advanced. And comes this one. If you know the concept behind this, you should be able to do it. Give you 2 minutes. This question can be asked in a variety of ways. This question could come in your errors and measurements. Calculate the value of G and this is the error in this is the error in that. Getting my point, right? So this question is asked in various ways. So that is why I've decided to include this. I'll give you 2 minutes. A clock pendulum made of inward has a time period of 2 seconds, which this is known as a seconds pendulum. Okay. Um, if the clock used in the climate where average temperature is 40 degrees Celsius, what correction in seconds may be necessary at the end of 10 days to be given
सर
by the clock?
SHM का टॉपिक नहीं आया था सर मुझे
क्या बेटा?
SHM का टॉपिक नहीं हुआ सर
SHM का topic नहीं हुआ sir, but this is not a question of SHM. This is thermodynamics. You know the time period of a simple pendulum, 2 pi root over
Yes,
L by
2
G.
pi
Yes
by
or no?
root or L by G.
Have you gone through the chapter in calorimetry where they tell you how much fast or how much slow the pendulum gets with time? Do you know that?
Yes, sir.
That is what you need to apply here, nothing else.
Okay, sir. Just
Time gained or time lost has got nothing to do with simple pendulum. It is not going to do time period. 2 pi root over Lg, you know that. So I'll give you 2 minutes to do it. We are doing all sorts of questions so that I will know what you know and what you don't. And if you have any doubt in anything, we'll clear it up. Don't worry. Question.
Calculation आ रहा है 1 मिनट सर
Well, the calculation is pretty simple. Just remember this formula. Time gained or time lost per
Yes.
second. Do you know this
6
formula?
6 seconds. Yes,
6
sir.
seconds. Okay. Just remember this formula, beta. Time gained or time lost per second is half alpha delta theta. You just calculate it, multiply it by the number of seconds in 10 days, and you are done. You understand this? See, if this question comes in a
Yeah.
JEE, they will not give you all this numerical value. They'll probably just give you the answer in terms of alpha, beta, and gamma. Do you understand this?
Yes, sir.
Okay, comes this one. And I hope you can do this. A rod has variable coefficient of linear expansion alpha. The length of the rod is 1 meter. Determine the increase in the length of the rod or increase the temperature by 100 degrees Celsius. So alpha is not constant here. Alpha varies with x. Alpha can vary with temperature as well. So to understand one part, you can do the second part. Yes. So here in this question, alpha varies with x, and I'll give you 2 minutes to do this. So what do you do in this question? You move a distance x, then you take a small element of length dx. Do you understand this? How much is the change in length of this element dx? That will be alpha into length of this element, which is dx, into the change in temperature delta T. delta theta, which is same. The alpha value of alpha is x upon 5000. The length of this segment is dx, and the change in temperature is this. So the change in length will be this much. You just integrate it from 0
Yes,
to
sir.
L, and you get your answer. Do you understand this?
Yes, sir.
It's what pretty straightforward. The reason I did this was that if a question comes, you should know the approach. If you know the approach, you will be able to solve it quickly in the examination hall. JEE Advanced is again, I keep on saying this, 70% speed of your test. You can do simpler questions correctly, fast. You would get time for that 30% questions, which might require some time. Come on to the last question for this class. The specific heat of a metal at low temperatures varies according to the law. S is 4 by 5 T cube, where T is the absolute temperature. Find the heat energy needed to raise unit mass of the metal from 1 Kelvin to 2 Kelvin. Simple question. I give you 2 minutes to solve it.
Q equal to integral ms delta t.
The answer was very quick. I appreciate it. Well done. I don't need to tell you how it is done since you know this already. Well then, let me take one more small question if it is possible for me to take it. Okay, there is no smaller question. So what I'll do is we will start with the next question in the next class.
Okay, sir.
And we'll try to cover it up in the next class. Okay, so the time is already over. I'll show you one question. If I'll want you to try this, so try this one. This is question number 48, and this is a question based on pure calorimetry. In an industrial process, 10 kg of water per hour is to be heated from 20 degrees Celsius to 80 degrees Celsius. To do this, steam at 150 degrees Celsius is passed into a boiler and a copper coil immersed in water. The steam condenses in the coil and is returned to the boiler at 90 degrees Celsius. How much kg of steam is required per hour to do this operation? This is a simple question based on calorimetry. It will review your concepts in calorimetry, and that would be, I think, good enough. Okay, so that's today's class on thermodynamics. We tried to cover the different processes, polytropic process. We did some questions on conduction, calorimetry, KTG, and all. Okay, so we'll meet in the next class tomorrow, and we will go ahead with the next topic. Okay, till then,
Sir, is this enough for a J advance or you have to practice extra some more things?
for beta what?
Advance के लिए ये बस ना sir.
I think this is more than enough that you will require. I mean, I don't see any question in thermodynamics coming more than this. If you want, we can do more questions on thermodynamics on different topics, heat transfer and all that. I can do them separately as well if you want it. But maybe in heat transfer, you might require some questions. Calorimetry, I don't think you'll require. KTG and heat transfer, you might require more practice. So if you want, we can cover those topics in the next class. Okay.
Sir, thermodynamics से तगड़ा वाला questions और दूसरा.
You want more question on thermodynamic processes?
Yeah.
Okay then. So in the next class, we'll try to wind up thermodynamics with more question on thermodynamic process from KTG. Because KTG and thermodynamic process will come, and then we'll try to cover some questions from calorimetry and heat transfer as well. Okay. Is that good enough?
Yes, sir.
Okay, then we'll do that in the next class. We'll try to wind up thermodynamics with more questions on processes and on KTG and heat transfer, because these are the three topics from which questions will come. So see you in the next class tomorrow. Take care and have a good night, beta.
Yes, sir. Okay.